So good evening, ladies and gentlemen. Once again, welcome to the International Conference on Information Technology and Digital Application 2020. I'm Sean Lim from Taylor's College, Malaysia. It is my honor to be a moderator for this session. So far, we have seen an array of outstanding presentations from our prominent presenter, and I believe they have enriched our insight and knowledge regarding the theme of this conference. For this coming keynote speech, it will start by a 50 minutes talk and followed by 20 minutes Q&A. So for Q&A session, participant, you can actually use the raise hand features in Zoom or type your questions via Zoom chat room. Before starting the next keynote speech, may I briefly introduce you our keynote speaker for this session, Dr. Elena. Dr. Elena graduated with a Ph.D. in machine learning from Radboud University in the Netherlands. Currently, she's a manager of machine learning team in Facebook. Her job scope is to lead a team of machine learning engineers to automate customer service department with machine learning and natural language processing, or NLP. Before serving the current employment, Dr. Elena also worked with companies such as Amazon Alexa and Booking.com in the related field. Throughout the year, Dr. Elena has successfully delivered her industrial presentation in European Women in Tech Summit, Women in Big Data Conference, Deep Learning and AI Assistance Summit, and many more. Besides, Dr. Elena was nominated for Data Leader of the Year in Europe for Women in Tech Award 2019. Ladies and gentlemen, please join me to welcome Dr. Elena to deliver her keynote speech entitled How to Make Machine Learning Works in the Industry. Dr. Elena, the session is yours now.
Yeah, thank you very much for such a nice introduction, and I'm really excited to give my speech today. Unfortunately, we are not doing it in Indonesia. That's a bit of a pity, but I hope that you can still hear me well, and I can share my knowledge today. Let me share my screen.
Sure.
I hope you can see the presentation now.
Yes, we can see.
Okay, thank you everyone. And today I would like to share my experience working in big international companies like Facebook, Booking, Amazon, where we were working on implementing machine learning to production. And I would like to explain how does this experience differ from experience when you're working in academia, and what exactly big companies do to make machine learning work in reality and make it profitable. So the first question before we go actually to the topic of our discussion is, why can machine learning fail? And there are multiple answers for that. So maybe if you have some ideas, you can also put them in comments, or your experience with when machine learning was failing in your company or in your project. There are tons of reasons for that. Problems with data, wrong expectations, lack of experience. And a very, very typical reason for that is that when you come to the company, there is a strong belief that machine learning is a big magic box. You put any problems there, in a day, it's out, everything is solved, works perfectly, no investment is needed. Does it work like this in practice? Obviously not. And this is the reason why I want to do this presentation, to tell you how exactly can we make machine learning work, and where in practice would it fail, and how to deal with it. So the main two things that I want to discuss today is, where can machine learning help exactly? Because this belief that everything you put in machine learning will work is not true. So I would like to give you good examples of where it was actually successful in big companies, and how you make it successful. how can you build it so that you wouldn't spend tons of money, 10 years, and don't get any results. So let's start with the first thing. Where can machine learning help? And here I would like to talk about different examples so that you will get a flavor of where machine learning is actually helpful. I would not tell you all possible areas where it actually works, but I hope that these ideas can bring you a pattern, and then you can think where they can work in your specific industry. So the most common areas, if we look at machine learning, are on a web. So for example, if you have a website, everything you demonstrate to the users, like a list of hotels like in booking.com, a list of products like in Amazon, newsfeed like in Facebook, you can rank it. And everything that you demonstrate, you can rank or prioritize, make more contextual. Inside of the company, there are usually huge departments of machine learning in marketing. Why? Because when we send something to the user, it has costs, and we want to optimize our return on investment. In operations, this is a part of the company that people usually don't see unless something goes wrong. But this part is actually one of the biggest parts that requires a lot of manual work, where you call to the customer service if something is broken. Either your Facebook account is locked, your Amazon delivery has not been delivered on time. In booking, your hotel was canceled. You need to contact customer operations and fix your problem. And this is super costly. So machine learning can help this here as well. Security. This is another way where machine learning helps a lot. Because obviously, our world is far from ideal, and there are a lot of different attacks, malicious activities that company has to prevent. And because of the volume, it's impossible to do it by hand, but machine learning can actually capture very common patterns. Content curation. As soon as you actually want to put something on a website, you will get content. Either it's a description of hotels, description of products, any pictures that your users have to upload, you need to curate it. You cannot allow users to upload everything they want, just because the imagination of different people is different, and whatever you think is appropriate, some other people might not consider like this. And again, even if it's might be appropriate, but it might be completely irrelevant. And if you put a lot of irrelevant information on your website, that would make harder for other users to see the right content, and they might leave your website. So you need to be very careful on what you actually present there. So you need to have an opportunity to curate it. And obviously, because of the scale, it's almost impossible to do it by hand. This is where machine learning comes. And another common example is automatic assistants. Okay, Google, hi Alexa, Siri. These things are powered with machine learning from top to bottom. And in a second, I would like to talk about each of them in a little bit more details to give you real examples of where machine learning works here. So if you have heard this set of possible areas of applications, you can already start guessing what are the most common features between them. And if you think about it, it's more or less like what we had in the past. We had very non-automated factories where a lot of manual work has been done, a lot of repetitive operations that actually needed to require a lot of manual work that doesn't require you to think a lot, but they are very costly. So these repetitive operations that usually depend somehow on the context that are unscalable or human, but they improve business metrics. This is what we automate. We automate it with machine learning because they're easy. They're always the same. That's why machine learning can actually handle them. They require a little bit of context. That's why it's usually harder to automate them with simple things that is not machine learning, for example, as rule-based system. So we usually, machine learning gives biggest value where there is some context dependency. It gives the biggest value where we actually cannot do it by hand. If this is an operation that one person needs to do for 10 minutes once a year, then it doesn't make sense to implement machine learning. It should be really big volumes. And it should have an impact for the business. If there is no value in doing this, there is no point in doing this as well. Let's look at the examples now. So web, where in web we can see a lot of machine learning. As soon as we show relevant information, for example, booking.com, you can see the website. Immediately after you enter your search, you get thousands of properties that were found that you can user can choose from. But obviously, not a single user probably will go through 1,600 properties. So the ones that are the most relevant should be on top, so that user actually would book something. And the more pages user needs to go to the relevant item, the more friction user has, the lower is the probability that user will actually select something and would not churn from the website. So machine learning actually brings a lot of impact. Every time we can show relevant information as soon as possible, reducing the steps for the user to get there and reducing this user friction. So if you want to rank something, if you want to show something to the user and you have a big database, here where it's standard things like recommendatory system, ranking, they play a big role. And don't think about it as only things like here, properties. This is very straightforward. But on this website, you can have tons of other things that you can rank. All the filters that we show to the user, all the possible dates where user can book his or her property. So actually, when you look into the website, almost every button that you have has some kind of machine learning behind it. Let's look at marketing. Why machine learning helps in marketing? Why can't we just send emails to the users with our recommendations every day? And shouldn't we send like 10 emails per day? Probably the answer is for that. As soon as you will get 10 emails from Netflix every day, you will truly hate it. You will put it into spam, you will unsubscribe, and you will never see it again. So when we want to use marketing, machine learning can help us to identify, or basically to even optimize the function. When should we send an email so that user will look at it, but we should not send it too often so that user would not unsubscribe. So balance unsubscription versus readings of the email so that users actually go through the link and select our product, our item. And here, the important factors are probability that after user reads the email, he or she will actually go to our website versus probability of churn. Both of these probabilities we do estimate with machine learning. And we try to estimate when one probability is higher than the other. And also one important thing is the cost, because even though we think that sending emails is free, it's actually not free. And generating all the content is also not free. So we should think about it and try to make an optimization function where we balance all these three options: costs, probability of churn, and probability of a click. And at the end, we define our return on investment and decide what exactly we are going to send and to which users with which periodicity. Another great example is operations. So while working both on booking and Facebook, I am actually working on optimization of customer service operations, where we get thousands or millions of different emails or phone calls or messages, all different channels of communications with the user to the company, and we need to reply them. To be able to handle it, you need to hire a lot of customer operations agents. This is a problem because they need to speak tens of languages. They need to work 24/7, be represented in all possible countries. And as soon as our traffic grows, we will get more of these questions. We need to hire more people. So this is not scalable. This is where machine learning can help. And why machine learning can help here is because these kind of requests, although they are text, they are often exactly the same. When is my check-in date? Why my account is blocked? My account was blocked. Can you unblock my account? So similar things like simple things like topic classification on the text works perfectly here. And also incorporating information about the context of the current user state. For example, whether a user is actually blocked. That can be a good predictor of the fact that user is actually asking about the blocked account. If the user's check-in date is in 20 minutes or is tomorrow, then probably it's something about that. Or if the payment is blocked, that already is a good predictor for us that the question will be about payment. So these things really help us to automate communication with the user, because we can detect what user is asking about. Try to auto-reply it. If we cannot auto-reply it, we can show the user a set of possible answers. If user we need to rank it with machine learning, so the most probable answers would be on top. If we could not rank it correctly and user still wants to contact us, for example, as you can see on the picture, where user went through all the proposals and actually decided to press a button, send a message, then we need to send it to the right agent. For that, we need to have machine learning algorithms that determine routing, prioritizing the right agent with the right skills, right priority. And this this information we don't have. We also predict it with machine learning. How urgent is the question based on the sentiment? What is the topic of the questions and how does it map to the topic of the expertise of an agent? What language is the message? The fact that for example, I'm from Russia, but the fact that I will be typing in Russian is not always the case. I can be typing in English, and we need to determine the language. We need to send it to the agent that knows the right language. And then we need to prioritize it, because we have tons of messages, and we need to decide which ones goes first and which ones goes second to the agent, so that we could solve the problems that has highest priority. For example, if someone's payment is not working and you need to check in tomorrow, that's a problem. If you are not completely sure about, I don't know, whether you have towels in your bathroom in an apartment that you want to rent, but your check-in is in 3 months, maybe you can wait for another 3 hours, and that's not urgent. So tons of opportunities for machine learning, and this is actually a really, really great thing if you have a company where you can save a lot of money on machine learning. Another huge thing where machine learning helps is security. And especially in huge companies where your volume is gigantic. And because you're a huge company, your volume is gigantic, that means that you will be also popular in any types of fraud, spam, malicious attacks. This is what comes with fame. You also have a lot of problems with security. And for that, you actually have gigantic departments of security in most of the big companies, where we work on fake account detection, spam detection. We need to prevent stealing of the data. We need to identify whether the claim that user is making is fake or true. There might be false advertising that are spread around the website, but actually there is nothing, and this is fraud that makes people pay for something that doesn't exist. Or there might be some misinformation that is spread on the website, which theoretically doesn't harm people in terms of they're not losing anything, but this is fake news. This is a big problem at the moment in the world of social media. And content curation, as I mentioned before, as soon as you open your website for users to put content there, to put reviews, feedback, upload their photos, that's a huge problem. On one side, it's obviously a great advantage because all of us want to share our opinions, but the way we share our opinions is different. And some people are a little bit less reserved than others, and you can get very, very bad messages, bullying, inappropriate content, inappropriate photos, spam, advertising that we don't want to see. When you, for example, if you look at the reviews of one restaurant, someone can put an advertisement of another restaurant there, or say that the restaurant was bad while the person actually hasn't been there, so it's fraud. So curation of everything, and by this I mean detecting if it's bullying, topic classification if it's appropriate or not, topic classification if it's not ad or not, determining or classifying basically whether this is a suspicious account. And all these things happen before we put something on the website. As soon as we put something on the website and your website is successful, you'll start getting hundreds, thousands, and maybe millions of these reviews. And users obviously wouldn't read all of them. So you need to make it easier for the users. And this is where summarizations can come into play. If you look at the websites like TripAdvisor, you would see that very often on top, you would see keywords, content summarization, like great restaurants for Asian food. And that might not be made because a restaurant provided it, but it could be made based on the summary of all previous reviews. And it can be summary of positive reviews, summary of negative reviews. And summarization is natural language generation. This is also a very, very big domain in machine learning. And this is a part that I'm also super excited about to talk here today is automatic assistance. This is what I was doing in Amazon Alexa. And if you think about this tiny little dot that you get on your table, which is called Alexa, or it can be a Siri, Google Assistant. This is quite amazing because what happens when you actually say something like, Alexa, what is the weather in Paris? Within a second, you will hear the reply. It is 27 degrees. What happens behind the scene in this 1 second, tons of different machine learning algorithms start working. First is automatic speech recognition, where from all this wave that is generated by our mouse, we translate it to the text. From text, we actually need to understand what is it talking about. And because it's not a person, it doesn't know. So here, natural language understanding, so things like topic classification pop up, and it splits it into between different topics, defines which topic is it specifically, and then it goes to dialog manager, which defines what is the answer, goes to the web, finds it extracts information. Then we go to natural language generation, because out of this information, we actually need to generate text. And this is another great example of machine learning. And as soon as we have text, our system needs to pronounce it. And this is text-to-speech, things I've been working for a while as well, which is super exciting because this is a state-of-the-art algorithms that take your text and pronounce it with the right voice, with the right intonation. And this is extremely difficult because even I can pronounce exactly the same thing millions of different ways, exactly the same text. For computer, it becomes even more complicated. So here we need to actually apply very, very complex deep learning technologies to make the text sound natural. And this happens within a second. So can you imagine how complicated this is to make it with such a small latency, go through all this pipeline and return you the result? This is amazing. Okay, I hope now you have a feeling of where machine learning can be useful. Now I would like to talk about how to build it, and not how to build it in general, because for that you probably could study machine learning on a couple of courses and try to put it in work. I would like to talk about how can you build it so that it would actually work and bring profit to the company. And to understand how to build it, I think the most important thing is to understand first where your problems can start. And with machine learning, the first biggest problem is this is high risk. When your boss comes to you and tells you, can you please make me a website, develop it, you know that by the end of, let's say, 1 month, you will develop it. If your boss comes and tells you, could you please develop me a machine learning model that would predict whether the user is talking about, I don't know, whether or not. If you actually cannot guarantee that you will be able to make this model, because you might not have the right data, you might not have the right model, and at the end, you might not have the model with the right accuracy. So you are working constantly with high risk. A second problem in machine learning project is this is also high costs. It's not a high cost when you are doing a course on machine learning on your laptop, but it becomes a high cost as soon as you want to make a machine learning model and you want to put it in production, you want to maintain it, and you want to it to be retrained. You want to run it on a big traffic of users. This all requires you a team of machine learning engineers, web services that will support it, maintenance, several software engineers that are actually going to build your infrastructure. And these all costs you have to invest even before you know whether it will be successful or not. And the last and the biggest problem is uncertain benefits. The problem is that, in fact, if you build a fantastic machine learning model, it works perfectly. It has 99% accuracy, or maybe precision 99, recall 99. It still doesn't guarantee that it will be useful for the user. Why? Because machine learning model is one thing, but machine learning model gives zero value on your website before you actually apply it somewhere. So, for example, if you're using it to rank your list of hotels on the website, the final product is actually ranking of the list of hotels, not your model. And if users actually don't look at your ranking ever, the benefit will be zero. Maybe you just put it on the bottom of the website and users never care about that. So even if you have the best model, if users don't care about this segment of your web page, you might have zero benefits. That's why it's very important to have very quick experimentation to identify what is the value of things that you're developing. And because of this complexity, when you are trying to introduce machine learning into your company, you need to understand there will be at least 3 phases of your project. And this is very tricky because most people think that as soon as you implement machine learning, you're on a phase 3. When you know everything is clear, everything is stable, you get your benefits. And the reality is that you usually start at phase 1. And I call this phase exploration. You don't have any data to build your model. You don't have any infra to run it in production. You don't have any clear vision of where machine learning will work in your company. You don't know whether it will be impactful or not to bring machine learning, or you can maybe do the same with rule-based system. You don't have any metrics to measure it because you don't know where should machine learning bring impact. And you don't have infra to run it in production. So in this first stage, the main goal is to do something that is called proof of concept. So something that is super simple. Usually you don't go for things like deep learning here. You use the simplest model you can build in one day with that super little data that you have. You put it in production as soon as possible. You evaluate your return on investment, how much profit machine learning actually gives you. You define promising areas, and you decide at the end whether you go or no go with machine learning for your company in this area. And the point is that no go can be also a good answer. So this is a 100% exploration phase. The second phase of the project would be transition. When you already know something about machine learning, you have some data, you started doing A/B testing to actually understand where the impact is. You have several proven areas with impact, and you have a little bit of infra that allows you to run the simplest model in production. And the main goal for this phase is to expand areas of impact, deliver stable results, start scaling your models and reduce your costs. And here it's about 50% exploration. So you're still searching where machine learning would work. You're still exploring all the risks, but 50% of the time you're already doing something that brings you benefit. And then there is a last part where I would call it more of an exploitation phase, where you have clear metrics, everything works as it should, infra is stable, you have a long-term vision, and here it becomes very easy to prioritize things, to prove the benefits for the management. And here, this is the part where we actually want to reuse costs, keep giving simple, stable impact. We make incremental improvements by improving our model accuracy maybe by 1-2% over the course of a month. Still, even here, we try to use 20% of our time on exploring new things. And 80% of the time, we are working in the area where we know everything. Because with machine learning, as with any product, at some point, machine learning will saturate. So let's say we will find our best model that ranks our ranking of the hotels. So we don't need actually to do there anything. So we need to think about the new areas where machine learning can work on our website. So what is the main challenges then in realization? The problem is that when we compare implementation of machine learning in science versus in reality, we make tons of assumptions that everything works. All your data is Gaussian distribution. You don't have any constraints. You don't care about latency. This is your plan in science, and this is your ugly reality that machine learning model, the most fancy deep learning model, works worse than simple linear regression. That you don't have data, that latency of 0.1 millisecond kills your product. That I don't know, your main developer goes on vacation for 3 months, and then you have no one to work on. So all these things is ugly reality, and you need to understand how you manage these risks. So how do we work with such a high uncertainty? We need to understand that high uncertainty for us as a project is not concentrated on whether your machine learning model, I don't know, the fanciest Roberta model or GPT-2 model will bring you accuracy of 95 or 96%. No, this is not where your problem starts and finishes. This is just a tiny percent of time. And in machine learning, you probably work on actual development of your model, maybe 20 to 50% of your time. All the rest of the time, you need to work on data collection. Then you actually do your model evaluation and model training. But even how to evaluate your model is a big problem. You need to build infrastructure. For that, you need software engineers. And you need to be able to evaluate user impact. In all 4 of these steps, you have problem. Everything can go wrong in each of them. And as soon as it goes wrong, it might mean that the project is canceled. So what kind of problems can happen on every stage? Let's look at them in more details. So the most obvious problem is the data. And although we are used to work in universities with big or small data, reality in production can be that you might start with no data. Really no data. What are you gonna do then? You still want to introduce your machine learning. You might be in a slightly better position where you have little data, but this is still a problem. There is nothing fancy about working with little data. You don't put articles on fancy journals, I work with little data. But this is actually the most common thing. You don't have big data, you have little data, even if you have tons of users. And the reason for that might be because you need labels for your data. You might have millions of users sending you some content. This is something that you can use as your input data. But in most of the problems, you need labels for this data. If you have messages, you need to have someone labeling which topics these messages are about, and you don't have it by default. So you need someone to see it and do that. And because it's costly, you will have very little of this. And you actually can have tons of data, but they are bad data that you cannot use it. Let me go deeper into each of these 4 problems, and I'll explain how you can actually solve them. So the first problem is no data at all. And the no data means not even like examples of the data. So you have no clue what will be the distribution of, let's say, topics in your messages. And you cannot evaluate the quality of your model because you have no data. So what do you usually do? You usually start in this case with artificial examples. So you just mainly write them by hand. Obviously, these examples will be far from what will be the real traffic that you'll get in your models. You use things like mTurk, where you give some examples and ask mTurk agents to rewrite them for you. That costs money, but then you can give some things. For example, you can say, give me 5 rephrasings for things like, for a sentence, can I book my hotel in Vienna? And then you'll get 10 different rephrasings of that. And this will be an approximation of how users can actually write this type of questions. And the most unintuitive things for people who really like machine learning and super involved into developing fancy deep learning systems is that very often on the initial stage, when you have no or little data, you don't start with machine learning. You don't start with simple classical machine learning algorithms like linear regression, no deep learning. You start with rule-based system, something where you say, if you see these keywords, this is topic A. If you see that keywords, this is topic B. Why? Because this thing you can implement in 1 hour. You don't need no infra. This is super easy, and then you can iterate quickly. Then you can put this model, which is rule-based system, into production, and you can actually start getting user traffic. And as soon as you get user traffic, you are out of this very bad place where you don't have data, because you can start evaluating a model, you can start getting real messages, you can evaluate distribution. So next thing is when you have little data, so little that you need a loop to actually see that. And we're in a modern world, we're constantly talking about the cases where we have millions of samples. What are you doing when you have 1,000 of samples? And maybe you have 20 different topics. So you have 3 different samples per topic, 20 different messages per topic, and you need to do something with it. And the biggest problem in industry is that when we look at our data, the distribution is super skewed. We'll have, let's say, 10 different topics that are super popular, and 500 other topics where you almost have no traffic, but you still need to build models for them. Or you might have 10 hotels in one city that are super popular, and 1,000 of other hotels that still cover maybe 50% of the traffic, but you have very, very little data for them. And the problem becomes even more complicated, because sparsity is not only in terms of distribution of the topics, but also in case you work with languages, as I work in my work, you have different languages. You might have thousands of messages for this topic, but if it's in 50 different languages, what are you going to do with that? And this is actually one of the most common problems now in the industry, because all these topics about big data is very far from reality, and we actually have little data. This is where transfer learning comes into play. And probably some of you have heard about GPT-3 or BERT models. That what they do, they train a general language model on the corpus of text that actually doesn't require any labeling, and it learns the language model of the, for example, from Wikipedia. And then we take this already pre-trained model and adjust it a little bit based on the small data that we have, so that it will work for this specific task that we have. For example, topic classification for, let's say, hotel industry. And in that case, instead of requiring 1 million labels, label the samples for your own data, you can live with only a small amount of data, where you can tune your model, your BERT or GPT-2 model, and the rest is done already on some unrelated data. So that saves you tons of time, tons of energy, and saves you a lot of costs. In case it doesn't work, if you have little data, you can also come up with artificial examples in the previous case. And in case you have little data and transfer learning wouldn't work for you, what you usually start with is very simple models. Training a model, a deep learning model with millions of parameters, when your data sample size of your model is, sample size of your data is maybe 10,000 examples, that wouldn't bring you any benefits. Your model will be extremely overfitting the data. So you start with something classic like logistical linear regression, and it might sound not super fancy, but this is very useful, and this helps you a lot, because first, big models are not the best one in terms of latency. They require a lot of training. They are training very long time as well. So this is actually a great thing to start at the beginning. And the next problem is you need labels. If you have thousands of topics, you need to have thousands of people to annotating it, or thousands of hours to annotate it. Human annotation is costly. And the problem is that in most of the cases, you cannot just do it once, because your traffic continuously changes. you need to do it every month or so. So you need to do a lot of annotations, pay a lot of money to make your to maintain your machine learning models. What do you do here? So there are also smart ways how you can do annotation. Active learning is the most common there. In case your model already performs well on some of the examples, it doesn't make sense for you to annotate these examples. What active learning does, it selects the examples where your model actually doesn't perform well and determines, samples these specific examples, send them to annotation. And by that, you actually, our experiments in booking, for example, we saw that we could reduce the amount of data significantly by a magnitude of several times, that if we do active learning versus if we do random sampling to that annotation. Another thing is, as I mentioned already, is transfer learning that helps you a lot to save the on that labeling. And you can also start random sampling for quality estimate. This is also somewhere where even if your model works well, you still need to do quality estimates of your model. So you need to do sampling of your model, not even for training it, but for estimating how it works. And here you also can do different smart ways of quality estimates. Okay, let's say we finally have a lot of data, but it's bad data. What do you do with bad data? And why data can actually be bad? Let's imagine we have our data, we have our labels. Bad data, in my world, is basically biased data. Let me give you a simple example why data can be bad. If we look, for example, at a case when we need to rank hotels on our web page that we show to the user. The problem is that the probability that the user will click on a hotel that is served on top versus a hotel that we show on the bottom of the page is different, irrespectively of how relevant they are, because the probability of the click of the user depends on the order of the items. So when we are trying to train our model, if we do not account for this probability of click, we, instead of learning which hotels are the most relevant for the users, we just learn in our models which hotels we presented on top of the page versus on the bottom of the page. Another problem is that we even don't show all the items to the users. So even the most relevant hotel for the user was on the page number 25 of our search result. User may never see it. Can we then say that this hotel was irrelevant for the user? Problem that we cannot. And then an even more annoying thing is the seasonality effect. Whatever was relevant for users in July, maybe let's say trips to warm countries and hotels with swimming pool, could not be relevant for users in December, because there they might go skiing and they want to have some hotels that actually, instead of swimming pool, have a ski lift nearby. So we cannot just train our model once and not retrain it through the time. So how do we fix these problems? So first one is estimation of position bias. And the great thing that we actually have in production when we work in big companies is that we can do experiments, and the experiments can help us to estimate the position bias. So the most common way how to estimate position bias when we learn the probability of clicking on a ranked list is to do order randomization. We start showing things in random order to the users and see whether exactly the same hotel that was positioned on different places, how does the probability of click has changed. There are a couple of problems here. We cannot just start showing you as a user everything in random order, because you'll probably get pissed off as soon as we show you something completely irrelevant. So you can usually do it only on a small percentage of traffic, and you should do it in a smart way as well. The other problem is that continuously we get a lot of data that had no clicks, had never been seen by users. For example, as soon as you add new products to Amazon, most of them have never been seen to the users as before we actually start showing to them. And not being able to see them, that means that we don't have any estimates of their probability of being clicked. This is a big problem, and this is where reinforcement learning usually helps a lot. The problem is that reinforcement learning algorithms usually have some kind of warm-up period when first you need to show things in random order, and then the system starts learning, and then it starts estimating the probabilities correctly. But this warm-up period is a big problem for the company because it means that in this period it will lose money. So you should be very careful when you try to put it in production. And the last thing is the seasonality effect. That means that we need to retrain models continuously. And we need to understand that the effect of our model that we estimated for July, that might not be the same if we estimate the effect in January, because the quality of our model can be different depending on the season. So this is a big problem for us as well. When we go to the model selection, we have a couple of problems here as well. And we need to be careful when we select which kind of model. If we have small data, that doesn't make sense for us to put the most fancy model in the world. It makes more sense to choose small data, small model. When we also think about all these fancy models that we see in production now, and in literature like GPT-2, GPT-3, BERT, they're not always good for production because they increase latency. And even if a model has an improvement of 3% in accuracy, if the latency increased by 3 seconds or 5 seconds, you will lose much more money. So very often in production, in big companies, although there are a lot of fancy models, they are not actually used when we put them in algorithms because they add latency. So this is one of the big areas where at the moment research in transfer learning actually is very intense, is that all these models like BERT and GPT-2, GPT-3, they are so big that they are not usable. And there is a distilled versions of these models where the number of parameters is much lower, but the accuracy doesn't drop significantly. So this is a big area of research in the industry at the moment.
I'm sorry to interrupt. Sorry to interrupt, Dr. Elena. There's 3 minutes.
Sure. And the last thing is unbalanced data that we have. And the problem here is also that we have a lot of data that might have distribution where most of the users have never clicked on it and only 1 or 2 users clicked on it. So the distribution of positive versus negative labels is very different. And then when we go to model evaluation process problems, we have a lot of problems here as well. As I said, your data can be biased. Your features online might not be the ones that you get offline. And the problem is that because your online and offline models, systems, infrastructure can be different. You can have observational data that you trained your model, but experimentation data might be very, very different distribution. And you can also have label leakage. Let me give you a couple of examples. The most typical problem when you actually see that your model has 99% of accuracy, which usually don't happen in practice. If you look at this, you need to go to your data and see if you have label leakage. When can we have label leakage? Is when we split our training, validation, and test data incorrectly. And especially when you have time series, if we put our test data before we put our validation data or training data, if we sample it randomly, then we can have our result already in our training data. And this is when you can have these great models when you have 100% accuracy. There is also a problem of observational versus experimentational data, where, as I said, we might figure out that the most important item for the users is to show hostels for them. But if we have never demonstrated it before, we actually don't have a way how we can check it without an experiment. So we don't have an information about things that we haven't had before in observational data. So if we demonstrate for the users this list and there are no hostels in here, we don't know whether it will be a click or miss for the user. And I think the most important thing is how are we going to evaluate the impact? And the impact evaluation is usually done in industry with A/B testing, where you have 2 groups, and you measure whether in one group the effect is higher than in another group. However, there are more advanced ways how you actually do A/B testing. You can have ABC testing. And this is very common for machine learning because the introduction of a model means that there might be an extra latency. So instead of doing A/B testing, you do A, where there is nothing, no change at all, B, where you load your model, but you don't show any change based on this model, and C, where you load the model and actually show the different ranking of the hotels, for example. And then you can actually measure what is the effect of just loading the model, what is the effect of your added latency. And sometimes this doesn't work. Not always you can do proper A/B testing because you might not be able to make an experiment. You only might have an observational data. It can be even unethical to do experiments in some cases, or it might be unmeasurable. And when we go to impact evaluation in that case, we can use causal inference. This is something that I was working in my PhD as well. So instead of doing random split, what you do instead, you do you do split that is not random. For example, you do split it by location, but you need to evaluate what would be the effect of splitting it like this. Why can we do something like this? For example, you might show advertisement on TV, but you cannot split people to whom you showed it and to whom you didn't show it if you show it on TV. Everyone in Moscow will see it, but then you can show it in Moscow, but not show it in London, let's say, and they see whether there is an increase in sales. And the last part is you actually need infer. You need to run models in production, build pipelines, dashboards, regression tests, and it all costs money. And you also need to be able to detect when you have something broken. And for that, you also need something like on-call. So in the middle of the night, someone can wake you up and say, your model is broken, please fix it. So all this you can achieve only if you have long-term vision and you know why machine learning is useful for you. So the main learnings for today is that machine learning for business is not a silver bullet. It cannot solve all your problems. It is and the fact that you made a great model is not the same that you get great impact. You should start small and not look at the most fancy models, but the ones that give you the biggest impact. And you should prepare for long-term investment if you want to actually make it work. And the last part is how can you make machine learning work for science? Is you need to understand where science can help us with machine learning. Work with little data, reduce labeling efforts, evaluate impact when data is bad, and reduce maintenance cost. Thank you very much for listening to this presentation. I hope you find something that you can reuse in your later work, either in university or in industry.
Okay, thank you very much for an interesting keynote speech. It's fantastic to see how these machine learning techniques are being deployed in the industry. And also closing the gaps between the academic research and industry practices is one of top priority in our School of Computing and Engineering in Taylor's University. We actually constantly seeking for collaboration, and also from the academic as well as from the industry as well. So looking at the questions, there are quite a number of questions need to address. So I actually summarized a few same questions into one. So firstly, participants would like to know what is the boundary between this deep learning and also machine learning, and also what's the Facebook doing now or will be doing in the next 10 years in this machine learning and deep learning.
Thank you very much for the question. It is a bit tricky to formulate what are we going to do in all deep learning. I can talk about the topic where I work specifically. This is natural language generation and natural language processing. And in this area, the biggest problem is data. So that's why you can see that, for example, Facebook, we developed the Roberta algorithm. This is a new version of a BERT algorithm that helps us work in transfer learning. And that helps to reduce the amount of data labeling and data in general that you need to train any model. This is the most common problem now in the industry, and I think it will be there for the next couple of years. Because first, we don't have a lot of data. Second, the models that exist now, they are still so big that they are not very practical to use in production. So having a model that have 100 million of parameters is not super useful. You need to have a model that will be small and will be easily adaptable for your specific tasks. So I think this is the area where the most common direction for development of NLP is at the moment for the next 3-5 years. I would not say what will happen in the next 10 years, but I think this is the direction for the next 5 years.
So yeah, I have another questions about the MLP. The participant asks, sometimes speech recognition like Alexa, Google's Assistant, or Siri cannot understand our speech well, although we have already communicated clearly. So what do you think about it, and what do we need to do as an engineer to improve it?
Yeah, that's a very big problem. So if you have, in one of my slides, I showed that there is a big loop between you said something and Alexa or Siri replied to you, because it's automatic speech recognition, extracting the right answer, combining the answer, and pronouncing. And the first step which is automatic speech recognition. This is one of the most challenging ones. The reason for that is that usually when you talk something to your assistant, you not talk directly to it. You might stand 10 meters behind. There might be some other noises. There might be someone else talking. You might have a different pronunciation. And that makes this a very complex project in terms of the standard automatic speech recognition that you see in science, where you actually take someone actually talking to the microphone. And splitting, disentangling the actual speech versus all the other noise is a very big problem in automatic speech recognition. Also working with different accents, different pronunciation, different out of vocabulary words. This is another big problem here. And these are the main directions where automatic speech recognition in the companies is now prioritized.
Okay. So I think there is another participants that need your help on this NLP. So yeah, the participant says that I believe our limitation is language itself. So let's say Bahasa Indonesia. So the participant actually give a link on the website link on see how they actually can improve on this initiative about this indobenchmark.com. So maybe Dr. Elena, maybe if you have time later, you can look at the link. And the other questions that we have, it's talking about this modeling. So how do you decide whether a model is ready to be deployed in the real system? Okay, in the real system, and what are requirements to met? Okay, or the threshold to be passed before deploying this model in the reality?
So, yeah, that's actually a really good question. So the thing is that in reality, that becomes not a mathematical question, but a business question. And a business question because the decision is made based on one simple thing. What do we gain if we put it in production, and what do we lose if we put it in production? And gain and lose are determined by your context. So if we put this model in production and let's say it increases our latency by 5 seconds and we lose 5 million customers per day based on this, and we gain 3 customers based on improved model, then we don't do it. We don't put it in production. It's also very interesting that in production, usually you don't aim for, let's say, precision 99, recall 99. This is something that is very common in science, because we try to make another more complex model, which will improve our benchmark by 0.1% new accuracy. In industry, you don't care about it. You would try to minimize the number of parameters, trying to minimize the complexity of the model, and would be okay to have 0.1% less accuracy if you can deploy your model faster. And you usually work in incremental deliveries. So you first deliver a simple model, then in 2 weeks you deliver a more complex model, and then in 2 weeks you deliver even more complex model. And every time you do that, you do A/B testing to actually measure if there is any effect. And one of the steps that we do in industry is that we do A/B testing. You see whether there is effect, and only after you measure this effect through A/B testing, you usually decide whether you put it so-called full on, so that you decide whether you keep it in production or not. It can be also that your model offline, when you evaluate it, it was working well, and online it doesn't work well, so you don't actually put it in product.
So I hope that this answer also answer the question from Nashin Hun. It's about the same questions. So I have the other questions. It's more general. It's what algorithms are used by machine learning in determining the trending?
Trending?
Yes.
Depends on what we mean by trending. Could you explain it a little bit?
I think it's maybe the participant would like to explain a little bit more. I believe just now in your slide there is one section. It's about trending, the trend.
Mm-hmm.
So,
well, unfortunately, I'm not sure what exactly we mean by trending here. So, okay. in terms of business, there can be different things. Okay. There can be things like what is the change in the distribution, and then you want to see the trend in terms of you want to detect anomaly, and this is time series analysis. Okay. If you want to just see, and for that there are different algorithms that you can use there. There can also be things like just a regular seasonality change. For that, you don't do any new algorithms. You just retrain your models continuously. And by that, you kind of try to remove this problem of continuous change in trends.
I think they have further explained on what is the training that they're referring to is gaining popularity.
Yeah, so for that, you don't even need to have a very fancy machine learning techniques. You can just calculate whether a distribution has changed. Sometimes when a website will tell you this item is trending now, that means that now versus day X, it has X amount of more views. It's more of a problem when you're trying to detect some anomaly, especially if we're talking about security fraud, when you have big spikes in your distribution of something that is not really normal. And then it becomes very tricky because of all the other things that make your distribution not looking like this, but looking like this. So we need to do some seasonality removal. So you need to remove all the seasonality effect, like the effect of the day, effect of the week, effect of the month. And then you can actually, while disentangling these things, you can determine whether there is actual spike or not.
I see. Okay, so another questions. So how was the boundary scope between machine learning engineer and data scientist in Facebook?
So you need to understand that every company names engineer, data scientist, research scientist, applied scientist. You can see all these terms, but in every company they mean slightly different, and they might mean in slightly different things within the team, between the teams. So usually a data scientist and in, let's say, Facebook or Amazon is a person who is mainly working on data pipelines. So you're building pipelines and you don't use machine learning necessarily that much. Then there can be something like machine learning engineer or applied scientist. These are the people who work with implementing machine learning models into production. So there you work more with machine learning. When you're a code engineer, you're usually less working on developing new models and more on applying them to specific product. If you're called applied scientist, you might be working more on developing actually new models, but also with a focus on putting them in production. And when you are called research scientist, you usually work on developing new models, more or less like in the university, where your main goal would be to write a publication. So there is usually no goal of putting things in product.
Okay, so we also have participants would like to know how this machine learning works on Facebook.
Can you repeat the question, please? How does machine learning works on Facebook?
Yeah, I mean, how the Facebook apply this machine learning?
Well, as I said, there are tons of different areas where machine learning is applied in the company. So the same holds for Facebook. And Facebook is actually very big because Facebook has not only Facebook itself, but also Instagram. It has also WhatsApp. It has Oculus. And so in Oculus, the application would be very different because Oculus works to, it's a virtual reality app, a virtual reality device, where there the main focus of machine learning is, for example, computer vision. In other areas, in Facebook, as I said, it's different types of rankings, content moderation. The same for Instagram, also working with a lot of messages and text and images. But because every single thing is usually has a piece of machine learning, it's a bit hard to say how it is applied in general. There are tons of different applications, and there are very, very many different machine learning teams, not only people, but teams who work on a single area where machine learning helps.
Okay. Thank you very much, Dr. Elena. So I think our time is almost there. So we would like to say thanks again for Dr. Elena for this informative and also interesting talk, and to the audience for your active participation as well. So this is the end of this keynote session, and until we meet again. So now I hand over to this session back to Nancy. Thank you.
Thank you very much.